Good morning and afternoon, depending upon where you're located today. For those of you that I haven't met over the years, my name is Stephen Dentler, and I'm the Chief Technology Officer here at RackCorp, and I'm thrilled to have everybody here today. Our topic today is Kubernetes, and it's one that's all about being at the forefront of modern cloud native technologies. As many of you have been witnessing and during our discussions, Kubernetes has become the de facto standard for generalized scaling and redundancy in applications. However, after having many of those conversations with you, we've all come to the same conclusion that navigating Kubernetes can often be very complex and very overwhelming for many of us. So that's really where RackCorp comes along, and we're looking to aim to solve some of those problems. So in today's session, we're going to explore Kubernetes, and we'll share some of the ways that we see that we can help simplify, secure, and optimize your Kubernetes environments. And our goal is that all of our partners will be able to confidently be able to support these Kubernetes environments for your customers, and do so with some confidence about the solution. So let's dive in. I'll hand over to Chris, and we'll learn how to tame and unlock Kubernetes. Thanks, Chris.
Thanks, Stephen. Hi, my name's Chris. I'm joined today by my colleague Des, and we're going to talk through the RackCorp Kubernetes service. There was a slide here, Stephen, just a bit about RackCorp. I don't know if you wanted to cover this off before we get into the service offering.
Oh, okay. Yep, great. Many of you already know RackCorp, but for those of you who might be a bit fresh, RackCorp's been around for more than 20 years, and our whole goal is to be able to deliver IT infrastructure and associated services out to our partners around the world. So, right now I think we're in 16 different countries. I think we're in 34 plus data centers for public cloud. And our whole goal is to enable IT companies to compete against those hyperscalers, be able to deliver better services than those hyperscalers, and do so at a price point where our partners can still make money on those deals. So that's really where we're coming along. And with Kubernetes, it's no different to all of the other products. We're still aiming to give you the exact same capability sets. Kubernetes is probably a bit different to the other services that we offer in that it's probably a lot more complicated than some of the other services. So I know a lot of you have shied away from taking on Kubernetes to date. So today's really about how all of you get some confidence in adopting Kubernetes for your customers, and how you can go out there and help them adopt Kubernetes. It is a great solution. It helps achieve this, again, the scaling and the redundancy. So, it is something that businesses need. It's all about just getting that confidence level up. And that's what today is all about. So thanks, Chris.
Thanks, Stephen. Just by way of an agenda today, I'm less technical than Des. So the first part will be me talking, around the business objectives, what we're seeing of requirements when we talk about Kubernetes as a service. Obviously going to give you an overview in terms of what that service offering is and the benefits of it. And then Des, towards the end of this session, is going to get into the technical details and also show you a demo. There are three things to take away from today's webinar. So number one, the RackCorp Kubernetes service will cost you less than trying to do it yourself. That RKS is your Kubernetes team. And then finally, with those two, we think this is going to allow you to focus on your business goals rather than spending all of your time thinking about the infrastructure. Where are you on your Kubernetes journey? And the reason why we ask this is I think we've seen a range when we've been talking to people about RKS, is that we have those who are just exploring it for the first time, maybe some who've started to explore it and realized that there are some challenges involved with deployment. And then there are those who are ahead of this and actually deploying this across the organization. And so obviously, depending on where you're coming from, you're going to get something different out of this presentation. But I think it's a good question to ask yourself where you and your organization is at on that journey. For me, whenever I talk about technology, I think it's good to think about what's driving that requirement from a business perspective. And so as you're engaging with your customers and your clients, whilst we're proposing a solution called RKS here, it's worthwhile revisiting why they're looking at this. Is it to generate more revenue? Is it to reduce cost? Are they looking to reduce risk in the enterprise? I think let's just make sure we're understanding why someone is adopting a technology or trying something new. And then through that, what we've seen is these common set of requirements from people exploring Kubernetes. So the first one is, one thing that we hear a lot is that organizations are trying to launch fast and get these business initiatives to market quicker ahead of competition, especially in today's market where things are moving increasingly faster. This is becoming very important. The second one is making sure you have predictable costs when you're planning out this new venture. I think a lot of people have been burnt by unpredictable cloud costs on a month-by-month basis. And if you're a business executive trying something new, you have set out a budget, you've set out some goals, and you need to know that you're going to meet those in order for you to move ahead with the project. You're obviously concerned around security. There's obviously lots in the news every day around attacks. And so one of the big things is around making sure that your brand image is protected so that your site is always up, that your site is always secure, your application. And in this market, as we're going to talk to, in order to run Kubernetes, you need some highly skilled, probably expensive resources. And then you've got the question of how do I achieve this, but I want to minimize my risk of hiring or even retaining my skilled people in my organization. And then similarly, those people in my organization who are the highly skilled people, perhaps I'm better served at putting them towards achieving business goals than just worrying about the infrastructure layer. And then finally, a requirement that we hear more and more common is I need my cloud, my application service to be running onshore in my own country within a sovereign cloud. So you may look at this set of requirements, you may have other requirements, but these are a common list that we hear quite often. And as you're going through this process, we're going to obviously track why we built RKS to meet these requirements that we were hearing from our customers. So a little bit about Kubernetes. So back in 2006, Google built a system called Borg. They did this to run their data centers, obviously to power their internet search service. And it was their answer to efficiently running millions of containers. So long before the word cloud or containers became a thing, Google had created this to run their own operations. They created an open source version of this called Kubernetes. So a way for organizations to run complex, large scale infrastructure with that same discipline and automation as Google. And then in 2015, they donated this to the Cloud Native Computing Foundation, or the CNCF. And as some of you might know, the CNCF is a non-profit group. It sits under the Linux Foundation. And their job is to steward critical cloud technologies, making sure that they're open, that they're vendor neutral. They're not just driven by one company, but they're driven by a community. And so through all of this, Kubernetes quickly became the standard for modern computing applications, and then had support from the major tech players, Microsoft, Amazon, IBM, Red Hat, and many more. So today, enterprises have the same data volume as Google had back in 2006. And they're using it and they're highly adopting Kubernetes in order to run their enterprise business. So what are the benefits of Kubernetes? There are four main benefits. The first one, scale and performance. So Kubernetes isn't just a system for running containers. It's fundamentally an orchestrator and scheduler. So that means it decides automatically which containers run where, based on the resources available and the needs of your applications. So you can kind of think of it like an air traffic controller for your workloads. So when demand spikes or hardware fails, an orchestrator can shift workloads around to keep everything running smoothly and efficiently. And this automation is essential for running performance at scale. And you've also got Kubernetes simplifies the process of scaling applications in response to changes in demand. You can either manually scale or you can automate that scaling. Kubernetes is renowned for being resilient to failure. So it continuously monitors the state of your applications and infrastructure, detects failures in any of the pods, and automatically replaces those. And then it can distribute network traffic to balance load across your infrastructure so that no single node becomes a bottleneck and doesn't impact your application's performance. We talked a little bit before about the enterprise ecosystem with Google and CNCF, and then lastly around application quality. So Kubernetes ensures that you have that consistency of deployment across your different environments, dev, UAT, production, and that allows you to perform rolling updates to your applications, ensuring that you have zero downtime during deployments. So with all of those advantages and this widespread adoption, I guess, part of this presentation is to kind of question, what has stopped you adopting Kubernetes today? And you can obviously answer that question. If you're in a group, you can talk about that amongst yourselves in terms of what stopped you in your organization. But these are some of our again, on the right-hand side, what we typically hear when we talk about RKS. And the first one is really around the complexity. So Kubernetes is complex, does require in-depth understanding for it to be managed effectively. And then to do that, you need to have trained, skilled engineers to be able to run Kubernetes, and these can be expensive. There is a learning curve associated with it. It takes time for teams to adapt, to learn and run Kubernetes and all the different components. There is a maintenance overhead. Des is going to talk to a little bit about this later on. So the ongoing management and troubleshooting requires constant attention. You need to be able to understand how to integrate it with your existing tools, and there may be some compatibility issues. You've got to worry about security. So it's a distributed system with layers of complexity that you're going to have to make sure they're secure. And then finally, around the cost of infrastructure. So running Kubernetes on clusters at scale can lead to higher infrastructure costs. So I think all of these things are questions you have to kind of understand as you're approaching this. And what we're trying to do with RKS is remove all of this complexity for you by offering this as a service so that you don't have to worry about all of these challenges. So without RKS, if you've tried Kubernetes, you're going to have not only your team building out your new applications to take to market, but you're going to need a team focused on Kubernetes. And they're going to be very much focused on the infrastructure, trying to make that work. What we're proposing with RKS is that RKS becomes your Kubernetes team, that we are a fully managed Kubernetes as a service offering, which means that you and your team can focus on your business initiatives rather than spending all of your time worrying about the infrastructure layer. If we look at what RKS is in comparison to the major providers of Kubernetes service, so within Amazon, within Google and Azure, if we go back to those requirements that we talked about at the top of the presentation, so we talked about launching faster and the predictable costs and so on. If we line up those services and against RKS, what we've done when we tried to build out RKS is make sure that we're meeting all of these requirements. I mean, we do acknowledge that you can launch fast and you can make sure that your Kubernetes is secure and it's going to be uptime, but you're going to have to throw a Kubernetes team at that in order to achieve that goal. So what we're trying to show you is that we can meet those requirements, but also as a service without you having to load in your own personnel to achieve it. Bit of an example here. So recently, back in March, there was a significant vulnerability that was discovered in a widely used Kubernetes component called the Ingress Nginx controller. So in basic terms, the component manages how traffic from the internet reaches the services running in your Kubernetes cluster. And the floor allowed attackers to potentially bypass all the security controls and gain unauthorized access to the internal systems. It basically left the front door open for anyone who knew where to go and look. And obviously, this is a massive, serious risk that could expose sensitive data or compromise your entire application. So for RKS customers, as soon as the vulnerability became public, we acted immediately. We assessed it to our own systems to confirm whether we were affected. We communicated transparently with our stakeholders to make sure there were no surprises or uncertainty. We put temporary mitigations in place to ensure that public-facing services weren't exposed. And then we worked through the patching into our test environments, then pushed those to production to make sure that the issue is fully resolved across all environments within 24 hours. So these kind of emergencies will crop up. I think it's important to acknowledge. And I think instances like these are exactly why it's critical to have a team of specialists running your Kubernetes platform. So vulnerabilities are inevitable. The difference is the speed, rigor, and transparency of how you respond to those. And most organizations just simply don't have the expertise or resources to keep up with fast-paced security issues or coordinate a response to those. With RKS, you'll get proactive monitoring, clear communication, and a proven process for quickly resolving these issues, protecting your business and your reputation. Now I'm going to hand over to Des to get into some of the technical details.
Thank you, Chris. If we could move to the next slide, please. Okay, so this slide is really just portraying what it actually means to have a fully managed Kubernetes as a service offering. And what we can see is there are layers of the stack. And starting from the bottom, we see that the data center is taken care of by RackCorp and is the virtual infrastructure, setup and management. And RKS, the RackCorp Kubernetes service itself, is also taken care of by RackCorp. So what that leaves is on the very top is the workloads that are deployed by the customer. And so this model means that it's a lot simpler to consume and use a Kubernetes cluster, and the customer only needs to be concerned with their workloads. If we could move to the next slide, please. So to dive a bit deeper into those management tasks that happen with the fully managed Kubernetes as a service, we've got a list here, which I'll just kind of iterate through some of those. We can see that, the things like the security patching for Kubernetes itself and also the nodes are taken care of. Those are the kind of things that your DevOps team would need to be on top of. And as Chris laid out with the Ingress Nightmare CVE, that was actually one of the most serious CVEs to hit the Kubernetes ecosystem. That really allowed significant access to a cluster using privilege escalation. And for those clusters that were exposed, that was a genuinely big risk. So as Chris described, we took care of the identification, the mitigation, the patching of that CVE, and at no time were the customers affected by it. So those are the kind of things that a DevOps team would be responsible for and would have to act very quickly on. But also there's things like upgrading. So Kubernetes, as you may or may not know, goes through very frequent upgrade cycles. They try basically to upgrade or produce a new version of it every 3 months. And certainly with other clouds as well, that's really forcing the DevOps team that's consuming, for instance, an AWS EKS cluster. It's forcing them to really keep on top of the upgrade cycle, which also can use up a lot of DevOps time and resources. And the upgrades is something that is taken care of by RKS, being a fully managed service. And that would also be in partnership with the customer. So the upgrade would happen at a time that was agreed. And by the nature of Kubernetes, it would generally be a zero downtime upgrade. But everything would be coordinated, so it was communicated clearly. Things like fixing issues, because they do arise from time to time, that's also taken care of. So there's monitoring on all of the clusters, and that includes some things like predictive monitoring. So we can actually get ahead of problems. For instance, like on a file system filling up, we can do a predictive alert on when that might actually be fully consumed, and therefore take action before that occurs. So other things that we can see there are things like the load balancer creation and deletion, storage resizing, that's going to be automatic as part of the service, creating and deleting nodes. So those are the range of tasks which would be done by RackCorp, as opposed to you having to have a DevOps team full time to actually manage all of those tasks. If we could move on, please, Chris. What we have on this slide is a depiction of a standard RKS cluster. And so we first of all, at the top, we have the control plane. And the control plane is composed of 3 nodes. So it's highly available and fully redundant. A failure of 1 or even 2 nodes does not take the cluster out, it still functions. Then the next tier we have there are the tools nodes. So on the tools nodes, we have like the storage solution that is used, which is called Longhorn. We have the monitoring, alerting, observability tools, and any other tools that we manage as part of the cluster management. They would be allocated to the tools nodes. Then finally, we have the worker nodes. The worker nodes are where the customer workloads run. And there can be any number of those of any size and shape, CPU or memory or disk capacity. And if we move on to the next slide, please. What we can see here is another depiction of an RKS cluster. But this time, if we look at the worker nodes, we see that it's actually carved up into 3 groups. So this is how we actually deploy the RackCorp AI service. And the reason to have separate work node groups is that you have workloads that might consume very specific requirements for their resources. So for instance, they might need GPUs. And in that case, GPUs are very expensive and you wouldn't want those to be allocated to all the nodes. So what you can do is you can have a node group that has those GPUs, and then the AI workloads, for example, can be deployed to that node group so that they're able to make use of those GPUs. But other workloads, standard workloads that don't require the GPUs, can be targeted onto a different node group. If we move on to the next slide, please. And this slide shows the separation of concerns. What it depicts is that RackCorp are responsible for the integrity of the cluster. So we monitor the cluster, as mentioned earlier, we have alerts that inform us if there's a problem with the cluster, and we automatically take action to fix that. And then we have the customer namespaces under the user project, and that is the administrative area within a cluster that the workloads for the customer are deployed into. And having those security boundaries on a cluster allows the cluster to be fully used by a customer, just like any other Kubernetes cluster, with access to all of the Kubernetes resources, but allows RackCorp to have an area where their tooling lives that is protected from the actions that might occur from deploying the customer workloads. If we could move on to the next slide, please. This example here, which is an animation, as we can see, is demonstrating that there's an easy onboarding capability from a current cluster, Kubernetes cluster, that the customer might use into RackCorp. So one of the technologies that we use is a technology called Rancher. And what that does is it allows us to federate in other Kubernetes clusters, whether they be AKS, GKE, EKS, or even just a vanilla Kubernetes cluster or different distribution of Kubernetes. And then by actually federating them into Rancher, the customer has a single pane of glass view where they can see their current clusters and their new RackCorp clusters. And then they could migrate their workloads like individually, one at a time, until they're finally all in the RackCorp ecosystem. So this provides an easy on-ramp to actually move into RKS. If we could move to the next slide, please. Okay, so what I'm going to do here is just give a very brief demo of the web user interface. So let me just share my screen. So I hope that everyone can see the cluster dashboard here. And
Yep.
awesome. So this is basically the web user interface that the customer would use. But as this is a standard Kubernetes cluster, they could use any of the tooling that they currently use as well, including CLI or other UIs like Lens, for instance, is very popular. If we look at this UI, what we see is on the left-hand side, we've got basically a number of menu options that allow us to look around the cluster, starting at the main page, which is the cluster dashboard. And from there, we can see things like how many nodes we've got and deployments, how much CPU and memory are used across the cluster, what the number of pods are that are running, and what the percentage is of pods that can be run. And we also see the events occurring across the Kubernetes cluster. So if we look here, we can see in more detail the nodes. And this is an example of a RackCorp AI cluster. And so this is carved up, the nodes are carved up into individual node groups, as I discussed earlier. So we have deployment nodes and platform nodes, tools nodes, compute and control. And then if we have a look at the workloads, so if you're familiar with Kubernetes, you'll know that they have a number of primitives that allow Kubernetes to describe an application. Deployment is generally the most used primitive, and in there we can see that we have a whole collection of deployments across multiple namespaces. A namespace in Kubernetes is where you collect together a logical grouping that makes sense to, say, describe an application or a part of an application. And namespaces are isolated from each other. So this is looking at the workload deployments, but they can be deployed as a collection using what's called a Helm chart. And from here, you can see the Helm charts that are available as standard within Rancher, but any Helm chart that describes a Kubernetes application can be used to deploy that application to the cluster. So if we look at the installed apps, these are the Helm charts that have been used to install into the cluster an application. And we can look at other types of resource within Kubernetes, such as the storage. We can see things like persistent volumes. There's basically a lot of different resources within the Kubernetes ecosystem. So I'm not going to go through all of them. I just really wanted to show that you have what is a very elegant and powerful dashboard that allows you to navigate around the cluster, to understand the state of the cluster, and to modify the state of the cluster to do deployments and upgrades, get the logs of running workloads, etc. So from here as well, we can have a look at, say, the Longhorn storage that's deployed into the cluster, and we can see how many volumes we have and the nodes that are schedulable and how much storage is available. And from this solution, we can also do things like backups that are automated, including shipping the backup off-site as a disaster recovery strategy. So without going too much deeper into it, that's the web user interface. So I think I will hand back to Chris. Thank you.
Thanks, Des. Okay, so that's kind of our introduction to RKS, and a bit of a dive into the technology and the demo around the service offering. Just wanted to cover off pricing and just talk a little bit about that, and then I think we're either open to questions, or obviously if you want to follow up afterwards, you're more than welcome to reach out to the team. So pricing, what I'm displaying here is our retail pricing. This is based on a price per month in US dollars. And obviously what I want to do then is extrapolate this out into some cluster pricing and kind of talk about how we map that pricing back to alternative offerings that you're looking at. So we have a comparison calculator. There's a lot of detail on the screen right now, but if I draw your eyes to the left-hand side, those yellow boxes are things that we can update. So I can compare this to the hyperscalers here. I can pick each one of those service offerings. We've taken their pricing from the Singapore, I think, location. Then t-shirt sizing, we just talked a bit about before. There's some different sizings you can deploy. We've put some t-shirt sizings together of a standard and a large and a small. You'll see in there's some other metrics I can throw in. These ones we've added for you, so no need to really update those. The big one though is that cost of your Kubernetes team per hour. So a lot of this calculator is talking about the effort behind running and managing and securing your Kubernetes platform. And so you'll have a different rate per hour that you'd want to throw in there, and that's obviously going to affect what the calculation looks like. So what then happens in this, it moves over to the middle section. Just as by comparison, you'll see that I've broken the cost down into my cloud and infrastructure costs, taken from that price point on the previous page versus the price point you'd be able to buy the EKS service for. And then the Kubernetes team, the section below that, you'll see that for RKS, what we've been trying to explain is that RKS is your Kubernetes team. So everything, the monitoring, the patching, that instant resolution, admin, that's all included in the service and included in the price. Whereas if you were to run a service on one of the hyperscalers, you're going to have a team that does that for you. And that takes the time and the amount of times that this happens and multiplies it by the rate that we've applied. And you can quickly see how that cost blows out in terms of running and managing that Kubernetes environment when you don't have it as a service. So what you have down the bottom is a total per month and a total per year. And then on the right-hand side, we've just extrapolated this out over 3 years. So in this configuration, at $100 an hour for that team, you can see that RKS here is 5 times cheaper than your alternative of trying to do it on your own on one of the hyperscaler platforms. So this comes back to where we started this. What are the 3 takeaways? We've designed RKS to be cheaper than what you're trying to do on your own. That we are the Kubernetes team, and what if we take out the pricing and the fact that we're running this for you, it just allows you to stop focusing on the infrastructure layer, which is there's no real competitive advantage to your business focusing all of your time on the infrastructure layer. Your competitive advantage is around on your business layer and getting your business goals, your projects to market to increase revenue, reduce cost, reduce risk, whatever those goals are of your clients. So hopefully that's been informative for you today. As I said, if you have questions, please reach out to the team. Yeah, I think that's it for today. So thank you for coming along.